Now we're ready to look at the product and quotient of two functions. Once again, I want to start by defining what exactly we mean by multiplication of functions. So let f and g be two functions. The product f times g is a function whose domain is the set of all real numbers common to the domains of f and g. Again, that's going to be the intersection of the two domains, defined as fg of x is f of x times g of x. In other words, I'm simply going to multiply the two functions together. Okay, so let's let f be 2x minus 1 and g of x be defined by x squared plus x minus 2, and find the product. I'm going to look at the domain first because I can. I know that this is a polynomial function, therefore all real numbers is my domain. This also is a polynomial function, so all real numbers is my domain. So the intersection of those two domains is going to be all real numbers. Now, to actually multiply them together, I want to take a minute to review box multiplication as well as I can anyway, simply for those who might need a refresher. So I'm going to write my trinomial across the top simply because I have more space that way, and my binomial going down the side. If you want to write in the plus signs, it doesn't hurt anything, but they're understood to be positive. Okay, then 2x times x squared is 2x cubed. Then x times 2x is 2x squared. Negative 2 times 2x is negative 4x. X squared times negative 1 is negative x squared. X times negative 1 is negative x. Negative 2 times negative 1 is positive 2. And if you want to write that out so you don't forget the plus, that's good. Alright, so I'm going to go through and add on my diagonals as I go through. So I've got 2x cubed up there by himself. Then I have a diagonal. My diagonal says 2x squared minus x squared. That's a positive 1x squared. The next diagonal says negative 4x minus x. That's negative 5x. And then I have a positive 2 sitting down there in the bottom right. That is the product of the two functions, with the domain being all real numbers. Now for the one that gets a little bit stickier, division. Let f and g be two functions. The quotient f divided by g is a function whose domain is the set of all real numbers common to f and g, that is the intersection of those two. But look at the definition. F over g of x, exactly what we think is going to be f of x over g of x, but look at the little stipulation there. Don't let g of x be 0. Thou shalt not divide by 0. That means I am most likely going to end up with something I have to throw out of the domain. So again, the same two polynomials, f and g. Let's find the quotient, and then I'll worry about my domain. Notice I'm not going to start off right off the bat, because if I do this first in this case, I would say it's all real numbers because both of these are all real numbers. But when I actually perform the division, f 2x minus 1 over g x squared plus x minus 2. Now, I don't know about you, but I can look at that and tell you I'm not going to be able to simplify it because there's no way 2x minus 1 is going to be a factor of that denominator. So I might be a little lazy and go ahead and box it in, but I'm still going to have to worry about that denominator. Why? Because x squared plus x minus 2 cannot be 0. How do I know if it is? I try to factor it. I get x plus 2, x minus 1. Cannot be 0. So x cannot be negative 2. and x cannot be positive 1. So when I state the domain of the function, it is no longer all real numbers. I can go up to -2, but then I got to jump over -2. I can go up to 1, but then I got to jump over 1. X cannot be -2 and x cannot be 1 because either of those numbers would cause that denominator to be a 0. So on quotients, there's a little something extra you got to pay attention to. You've got to be sure that you do not let that denominator equal 0.